Hello, hello. Are we live? Are we live? Okay, I'm now gonna be singing. Let me check if I'm live first. Yay, we're live. Let me check if I'm live first. Yay, we're live. We're live. So, let's see. I'm going to be playing very quiet classical music so you don't get bored when I'm not talking. The reason for today's live stream is, well, I don't know, I just want to play around with the new toy I bought. It's a little controller called ESP32. By the way, I don't like the sound levels of the music that I'm hearing. Ooh, I cannot control it from here. So, let's start again. Let me show you the device. It is ESP32. My phone doesn't want to focus on it. That's terrible. Let me see if I can zoom more. Oh. There you go. Yeah. Anyway, so what my goal is to turn it on and try to program it. And the longer goal is to write a program to connect it via Bluetooth to my phone, and from there transfer information, and then connect this controller to another controller that I have on a toy that I'm building, which is this little tank looking toy. It's make block Orion, and basically I want to be able to connect it from the phone, but the Orion has no wireless connectivity. So the goal is to connect it through this device and connect this device to the Orion, which is Arduino based controller, maybe through serial commands. So let's see. First goal is to put it into the breadboard, and the breadboard, maybe the breadboard is not good, but it doesn't really fit well. I'm not sure if I put it in, so I'm gonna just quickly check some of the connections to see if there's a connection between the breadboard and the pin of the device. Okay. Okay. Looks like we're connected. I mean, I'm not sure if I plugged it deep enough. Yep. So on both sides we have connection. So first step would be to connect it and see if it's gonna power. Obviously it was powered because I just disconnected in the beginning of the stream. So I already did some research how to start programming, and I'll quickly show you how to start. Basically we need to go to GitHub Expressive ESP32 and from here you just need to go to installing on Windows, Linux and Mac, and then here you need to copy the stable release link. Then you start Arduino IDE. There is also option to do this in Visual Studio Code, but I haven't studied how to do that yet. So in the preferences, sorry, not preference this one, but in Arduino preferences you can add this one here, and once you do, actually I'm going to load my sketch that I wrote. It's super duper simple one. So I'm going to close this one and maximize this. It's so from here you need to go to I don't see it, board, then board manager, and then the board manager you type ESP32 and there you install the latest version. Once you do, you can select the device from the list of devices, which would be, I mean, you're going to have a new section here, and even though my device was on Amazon, I bought it on Amazon as ESP, actually no, this is not the box from the pack for it, from it, it's this one. So if you look at the name, it says a high let go ESP room, W room, whatever that word means. But but unfortunately, in the list of devices, I couldn't find it. So if you go to ESP32, I tried this one room DA module, but it wasn't programming. So I tried with def ESP32 def module. This is the one that I managed to do anything with. So here are some settings. This is the upload speed. I think it should be 115200. I think I read somewhere that a higher speed is okay because this is a powerful device. The way I understand it is this. It's like 240 megahertz processor, I think dual core processor. So it basically emulates the Arduino on one of the cores, and that's why this is where you set on which core to run it. The important part is the port. The way I figured out where to plug it is by disconnecting it and restarting the Arduino IDE and just seeing which one is the device that is missing, and then when I plug it I see the new one. Actually, I'm seeing which devices are here without the device, and then when I plug it in I see which one is the new one. So this is the one that I have. Well, at the moment it's a little weird because I'm talking to myself only. Hopefully someday I can do something that people would like and watch the streams, but for now it's just gonna be me and trying to force myself to not get distracted and try to achieve a goal, because I don't want to record myself like reading random web pages. I prefer to, in this way I hope I can push myself to achieve my goal in a faster way and to be a little bit more professional. So yeah, going on to the code that I wrote. Let me just switch to cam and code. So initially this was supposed to be a blink, and then I just wanted to test if it's gonna only at least if it's going to even upload something to the device. So sorry, I'm a little bit sick. So anyways, what I would like to try now is to upload. So when I press upload and it's compiling the sketch. So on these streams I'm gonna most likely have a regular time in which I'm not talking and just researching stuff, so you can see in real time how I'm researching. You can skip forward if you don't like it. So far I'm talking constantly because the things that I'm doing I already know, because I already tried, but soon I'll start doing new things and most likely I will not be able to talk that much. One thing that I found is that compiling the sketch for this Arduino on ESP takes time. And there you go, we have our first problem. Request but did not find extension point with identifier Xcode ID kit blah blah. Why do I care about these things? Yeah, so now I have to press the button. Ooh, maybe I didn't press it on time. So one of the things that I learned is that there's two buttons on this controller, and every time when we try to upload we have to press this one. But I think I missed this moment, so let me try again. Okay, it seems successfully compiled. So I have to press start. Yes. Now it looks like it's uploading. Amazing. And let's see what we did. If everything was successful, I'm going to the serial monitor, should produce some information, and voila, we do have something. So let's try to change this to a reasonable to a simple blink schema sketch. I took a photo of the we call this the pinout of the of my tool of my device, but I didn't. Actually, I'm streaming with my phone, and that's why I cannot really see it. So I'm gonna go and quickly download this from photos on my Mac. And save it on a desktop. Okay. File, export one photo to the desktop. And export. Okay. So there you go. Here, this is the pinout, and I was watching a pretty nice video about it, and I'm gonna continue from there. Which one was that? It was this guy.
It's a bunch of GPIO pin numbers and not actual module pin numbers. Those will work fine. GPIO pin numbers and not actual module pin numbers. So just observe the same GPIO connections and you will be fine. You'll also need an LED and the dropping resistor for that LED. I use 220 ohms, but any value from 150 to 470 ohms will work fine.
150 to 470, okay. Ouch. Let's see how many ohms is this guy. This is in kilo ohms. Okay. Let's see. I don't want to read code, so I'm just gonna, oops. This is 1 kilo ohm. kilo mega ohms. What? Okay. Kilo ohms. 1 kilo ohm. Okay, it's the same color for God's sake. We need something smaller. 2 kilo, 1 kilo, 1, 3. Okay. What? Oh, this is 1 mega ohm. Let's see. Yep. This is 1 mega, 10 kilo, 1 kilo, 5.1 kilo. This looks like 220, 1K, 4.7K, 10 kilo ohms, 10. Okay, I have a bunch of those. I don't want to take out thousands of those. So I'm gonna just try this one. Change the range to kilo. Nope. Nice. This is 200 kilo ohms. Sorry, 200 ohms. Hold on. This is 0.21 kilo ohms. Okay, but why I cannot see it in ohm range? My multimeter is new. I'm still not familiar with it. Yes, 216 ohms. Good. Sure, I've used those before, but yes. So what did he say?
Dropping a resistor for that LED. I use 220 ohms, but any value from 150 to 470 ohms will work fine. You'll need a momentary 470 ohms 20D and the dropping resistor for that LED. I use 220 ohms, but any
Good. So let's see the pinout. Oops.
And you will also need a touch switch print to one side of the drop and another metallic device that you can attach a wire to. We'll begin by connecting the GPIO pin number 2 to one side.
GPIO 2. Let's see. So, if I'm correct, the first two are, let's see. Okay, the furthest more are ground and 3.3. Let's find a short cable to create our ground. We need to male. Do I have male to male? I should have some. Okay, male to male, yellow. Another yellow. Male to male. And déjà male to female. And there's some more. Okay, it'd be nice to have one red, but I don't have one. Okay, I have yellow, orange. No more reds. Okay, this is gonna be a backup here. Alright. So, if everything's correct, we should have 3.3 volts on the last two pins. And we do. And the bottom one is minus, it's ground. Yes. So now we can put the ground, to connect the ground to this rail. So we have a proper ground. And let's see. Hopefully we're not gonna see the magic smoke. And let's see where that pin 2 is. GPIO2. That looks different. 13, 5 volts. Oh, I have 5 volts. Nice. So I can do, yeah, I suppose I can do plus 5 volts. And this could be my rail. 5 volts, let's see. If I have 5 volts here. Be nice if I can plug in this from the first time. Yep, 479. This is good. But my pins don't look like his. P34R, P33. Jesus. SDD, SDA 15. P2, P0. Alright, I suppose P2 should be this one. So this is 1, 2, 3, 4. The fifth from here. So we're gonna count 1, 2, 3, 4, 5. Should be pin 2. And the signal from it goes here. And let's see. Actually, I'm gonna put the minus here, the ground here. This is my ground.
Side of the dropping resistor. The other side of the resistor will be connected to the anode of the LED.
Okay.
We'll then connect the ground.
So this one goes to here, and then from here we attaching to the anode, and then go to ground. Alright, if there was someone live and was watching to me, maybe you can say if I'm gonna blow it, but so what can I use for pointer to point for my virtual audience? So this should be pin 2. From pin 2 we go into this rail, then from this resistor we're going to, I suppose this is the anode. Let's see what
The ohms will work fine. Also need a touch piece of printed circuit. We'll begin by connecting the GPIO pin number 2 to one side of the drop-in resistor. The other side of the resistor will be connected to the anode of the LED.
Yeah, the anode, and then from there
we'll then connect the ground.
This goes to ground. Okay, let's plug it in and see what's gonna happen. For now, we don't have a new anything loaded. I mean new code. So we're gonna just try to see if it still works. Okay, hello Peter, my master. Kit. So now we just have to create this variable that defines the pin. Then we have to set the pin to output. I don't want to pretend I remember the commands. I'm gonna just go here, and he's doing LED pin, okay, digital right, LED pin high. The digital right, LED pin high. And then we should do digital right pin low. Okay. Let's try again. Yikes. Compiling sketch. Wow. I didn't expect it to take so long. Let's see. Successfully compiled. There you go. Nice and easy. Uploading the 234 kilobytes. Amazing. Amazing speed. Oh my god. But what I don't understand is why this thing is not blinking.
For the LED pin is, notice I set the ESP32 skin in the R4. Now P32, it's not quite the same.
But Why it's not blinking? Maybe I
as
should
an
not.
Arduino. Now you'll notice.
I thought it should go a bit down. You should pull it low in order to stop. But obviously not. It doesn't have that. It's logical to do digital write height, so you make 5 volts and then stop. It doesn't work like that. Come on. Oh yeah. Why like this? I suppose I was too slow. There you go. This is terrible. Okay, let's see. Serial monitor. That's weird. So I'm doing digital write. And then on waiting. And again digital write low. Oh, stupid. I need to put another delay because it turns it off and then on extremely fast and I cannot see it. Alright. Wow. I suppose this is the LED is connected to 2, so I don't even need this one. I can do this one directly. Awesome. This is awesome. Okay. So let me show you the bench. We have a blink. Blinky blink. So now question is how to connect it to Wi-Fi, to Bluetooth. So I'm gonna delete this and upload so it doesn't bother me with blinking. I mean, I deleted the extra code for the blinking because it's gonna bother me. Okay, so for now I'm gonna just disconnect the extra stuff for the blink because I will not do it. I'm not gonna use it if I need something to use for debugging purposes. I can use the built-in pin LED. I don't have any delay. So let's do delay 500. And in the meantime, we have to Google how to connect to
screen. Now there is
Bluetooth.
a Mac, so if you run into that problem, there is indeed a way to solve it. But otherwise, here we have our Hello World example about your own Wi-Fi network. Specifically, it's SSID, which is the name of the Wi-Fi network, and your passcode. So armed with that information, let's go and see how we can get our ESP32 communicating on Wi-Fi. Let's take a quick look at the Wi-Fi capabilities of the ESP32. The ESP32 supports Wi-Fi protocols 802.11b, G, and N. It operates at 2.4 GHz. Now to start using Wi-Fi with the ESP. Now this Wi-Fi example configures the ESP32. Turn it off. And it's very simple, but this is an excellent example of how you can remotely control devices using the ESP32 as a Wi-Fi access point. Now the final Wi-Fi sketch that we're going to be looking at today. The ESP32 has both classic Bluetooth and BLE, or Bluetooth Low Energy.
This is
The ESP32 can act as a Bluetooth client or as a server. You'd use classic Bluetooth for continuous data streaming. BLE can be used for...
Do I need to be client or server? Connect iPhone to BLE device. Server or client. Ah, that's stupid. It's supposed to be client. How to connect iPhone to BLE Arduino. Yeah, I think this is what I was looking for. This is very old because this was written in Objective-C. I think EOS BLE other which I think was server. So if Bluetooth is disabled in device enabled by blah blah, okay. Oh shit, I don't have device. I'm streaming with it. Okay, I'm gonna need to take my wife's phone. There you go. You're listening to Wagner. Let's quickly see how the stream looks like. Hopefully it's not terrible. Doesn't look terrible. Wow. I'm streaming for 45 minutes. I'm still on a blink. That's crazy. Okay, let's see. If we go to Bluetooth, okay, we're going to test also on the computer, because on the computer is easy to connect as well. Cannot see it. Okay, so we have to probably run something. Let's see. Bluetooth Daily Connect app provides iOS and Android devices with IT tools to communicate Bluetooth. Shit. Okay, let's see. App Store. Bluetooth Connect. There you go. Okay. The Android app is free, blah blah. The app compatibility device, Adafruit and possibly more. First off, install the app, enable location, blah blah. Okay. Yeah, I think this is actually the article I was looking for. Blah blah. Okay. I'm gonna use this code later when I code. Alright. Cool. Cool. Let's see. I see Crusher. Some other things. Watch. Blah blah. Most of those are unknown. It doesn't. Ooh, nice. Must have wild service. Cool, but none of it is working. Good. So we know about these services. Good, let's see how these guys do it.
Short bursts of data. There are Arduino libraries for Bluetooth and BLE that are installed by default when you install the ESP32 board manager. Some uses for classic Bluetooth are wireless headsets, file transfers between devices, wireless keyboards and mice, and wireless audio devices such as speakers. You would use Bluetooth Low Energy, or BLE, for devices like medical monitors, fitness bands, Internet of Things sensors, and also devices like iBeacon, which do targeted promotions. So now let's work with Bluetooth on the ESP32. Now to demonstrate the use of the classic Bluetooth, we're going to look at the serial-to-serial BT sketch. And this is a sketch that basically ties the serial monitor
Serial to serial. BT sketch. Sketchbook. Samples. Bluetooth serial, serial to serial Bluetooth sketch. There you go. So let's save this as in my folder. Developer, Arduino, serial to serial PT. Great. Save. Is that what he's using? Okay, so we do. Alright, good. But then I guess we have to do some configuration. Yeah, let's try it. Let's try to see what's gonna happen. So if serial is available, write what you sent, then we have to connect. And if serial available, alright. So it's writing in Bluetooth what you sent to this one, and serial what comes from the Bluetooth. So it's transmitting. Okay, this is exactly what we need. Wow, this is so slow. Let's run the serial monitor. The device started, now you can, wow. Started, now you can pair it with Bluetooth. Holy shit. Question is, which one is it? Let's see. First on the computer. Wow! Amazing. Wow, we're connected. Let's see if I disconnect. No, we're not gonna do the phone first, we're gonna do the computer. Question is, let's see how he's doing, so I'm not, I think it was ls dev/tty.usb star. Okay, I think it's gonna appear in the serial monitor. I know in the ports. Should we see Bluetooth incoming? Okay. What's the best way to do it? Is open another Arduino. And what do we set this one? The speed, serial Bluetooth. But at what speed it should, so the baud rate should be right, it's different question. Okay, close this one, I don't need this one. Ah, shit. How do I start new one? I just start from here, file new. And then this new should have a serial monitor. hold on, this new one we change to port to this one, and then we read see the serial monitor, and I want to put this one on the other screen, and then I'm gonna start the serial monitor of this one. Oh crap. But I guess you cannot change the port. Okay. Then I'm gonna have to use something else. So connect back to this one and show the serial monitor. Okay. And then we go to what was the name? Was dev /cu dot star. Okay, so we can do screen dev to attach to serial port with screen. Okay, only screen and def. Okay, and then it was Control AD to detach. cu dot is test. All right. So if I send something from here, it should come. Amazing. Nice, I'm typing now in the... Okay. Alright. Task 2 achieved. We have a chat between the Bluetooth of the computer and on the and the device. So Control AD to detach. So now, actually I had to probably QO screen minus screen. There you go. So now you have to disconnect it and pray that this device can be found on the phone, because this is the reason I bought it. So let's see. I don't know how to stream the phone, but I'll show you close up. if I find it somehow. Ay. Crappy apple. Nope. Cannot find it. But I can try to use this program and try to find ESP. Okay. ESP 32 test. Nope. Okay. Let's watch this guy's video example and see what happens. Good. There you go.
On your Arduino IDE to the Bluetooth serial. So basically anything that is received via Bluetooth is going to be displayed on the serial monitor, and anything that you type in and enter on the serial monitor will be transmitted via the serial Bluetooth. Now it's a fairly simple sketch. Most of the work is done by the Bluetooth serial library, and we create an object called serial BT, which represents the Bluetooth. And as you can see from the sketch, it's basically just tying the serial monitor to the serial Bluetooth. Now, there is one parameter that you may wish to modify. Serial BT.begin, where you start the Bluetooth, has the name of the Bluetooth device. And you can change this to any name that you want. And this is a name that you'll identify the device when you're connecting via Bluetooth. So I'm going to start the program right now. I'm going to open up my serial monitor, and I'm going to reset my device. And it says the device is started, and I can now pair it with my Bluetooth. Now, in order to use this, I've installed the serial terminal onto my Android device, and I have a link in the article that accompanies this video, so you can install the same serial terminal. There's also a link in there to a similar device for iOS, so if you happen to have an iPhone or an iPad, you can also use it as well. And I'm going to open this up right now, and in the terminal, I'm going to go and look for devices. And here is ESP32 test. I'm going to connect to it.
Serial terminal. I highly doubt that we have such thing for iOS, but okay. Store. Serial terminal. Serial terminal. TCP/IP to serial terminal. Let's try this one. Woohoo! There is BLE to serial terminal. Alright. My wife's gonna kill me when she sees how many things I installed on her phone. There you go. Amazing. This is gonna probably set a record for longest stream without anyone even watching it. Device list. Crap. Okay. Serial monitor. Fucking Apple. Guess I shouldn't curse. Okay. Cannot find it. Settings. Yep, Bluetooth is working. Crap. I suppose I have to do this from the Wi-Fi.
And I've connected to it. So now I'm going to type something. And a very misspelled hello, which we can now see up on my serial monitor. And if I type something in the serial monitor, you will see that that has appeared on my terminal, so I can communicate back and forth between the two of them. So it's a very simple example, but it's an effective method of seeing how serial Bluetooth works with the ESP32. Now, of course, the Wi-Fi and the Bluetooth capabilities of the ESP32 are the things that most people talk about, but as you saw at the beginning of the video, the ESP32 has a myriad of other features. It has all sorts of I/O ports, both digital and analog. It has touch switch inputs. It even has a Hall effect sensor built into it. So what I wanted to do right now is just go through some more of the example sketches using some of these additional features of the ESP32. Now, remember, you can take these example sketches and use them as part of your own code when you're designing for the ESP32. And so let's go and take a look at a variety of different ESP32 features. Now, the first of the extra examples we're going to be working with today is one called Simple Time, and I'll show you where I find this as well as all of the other examples I'm going to be using. So we go into File, into Examples, and scroll down to our ESP32 section, and you will find another menu called ESP32, which brings up this submenu. And you'll notice a number of things: analog out, camera, chip ID, etc., etc. This is where all the extra examples are, and the first one I'm using is called Simple Time, and it is under the Time section. So let's take a look at that. Now, Simple Time is a sketch in ESP32, which brings up this submenu.
Examples. ESP32. I don't think I have those. File, examples. Oh. Super timer. So what does it do? Connects to SSID, blah blah. And then on the serial connecting. Okay, and then print local time. Alright, fair enough. Good, but I don't need this. File, examples, ESP32. Camera, chip ID. Let's see this. Let's try to upload it and see. I start to like this chip quite a lot, this controller with this button. Nice. So let's see. Serial monitor. ESP, chip model 2 cores, chip ID, okay. Good, good, good. Stop. Stop. ESP now basic. Master slave, and this is for communication. I know this one is nice. Free GPIO. House sensor. Simple time. Repeat time watchdog. Touch button. This is BLE. I guess I have to Google. Wiring ESP32 BLE to EOS. Reddit. My answer is gonna be no. Ooh, what the hell you want? Doesn't want anything. Here at chapter 36 of this guide. I made sure that I need to use BLE for an iOS device. Does anyone have script where you can start BLE? What? Figure out that I need to use BLE for an iOS device. Does anyone have a script where you can start BLE? Okay. Page 36. No, chapter 36. Chapter 36. Guess should be table of content. Advanced audio. Blah blah. Yeah, I'm gonna read these, but not today. Okay. Currently in the same boat. This project script for archive BLE code is now included in Arduino directly. What? Alright, so we should have a script for BLE. Examples. SPI. Simple view. Oh. Alright. Let's just run this one and see what's gonna happen. I'm gonna read it while it's compiling. waiting for the light to blink. So, holy crap, what is this? If I'm configuring out, Bluetooth is not enabled, please run make config. I enable it. Simple BLE, one button, string out BLE name, plus milliseconds 0, port out, BLE begin out 0. Okay, set the bug true pin mode. We need a button for that. Pin mode 0, input pull up. ESP32 0 key. Press the button to change the device name. Okay. Let's see. Okay. Let's see if it's visible here. Not really. I'm gonna play with the disconnect because I don't want to disconnect my headphones. PLE stereo. Nada. And in settings. Should get an Android device for testing purposes. Nope. Okay, let's see what this thing does. Pin 0 input pull up. But this one had to have some resistors, I guess. SDK version. Begin with ESP simple BLE. Okay. But what's the difference? BLE, gain out. Ah, okay. Okay, so we're pressing the button, BLE name. Okay, good. Static last pin state 1, blah blah. Digital read on, okay. Yeah, but should I restart? Begin ESP32 sample BLE. Where does it say that? Yeah, we have. Now it is string. But Okay. Milliseconds divided by 1000. Print it, then start a new one. Okay. But how come the computer doesn't see it? I'll try on my Windows computer. I'm sorry, I cannot show it at the moment. I didn't think of it. I didn't think that I would need to share anything from this computer. But basically, I'm gonna just open the settings and try to search for the device. New Bluetooth device. There are 2 unknown devices. Press connect if pin on your device is matching this one. Alright. Okay, there's another unknown device. This doesn't look like it's enabling as if computer doesn't find it. That means it doesn't. Then make and enable it. Simple BLE. This shows how to use simple BLE. Advertise the name of the device and change it. Press the button useful if you want to advertise some sort of message. Button is attached between GPIO 0 and ground, and the device name changes each time you press the seconds. I'm gonna fully restart it. Let's see. CDL monitor. Clear. Not good. I bought several of those, and if iPhone cannot find them, let's read more. Have an issue Android device learning the same. Hi. Can be ESP32, Arduino app, let's see, what is this written in? Swift connecting controllers. Okay, this would be useful, but maybe it's just not possible to see it in the, yeah, yeah, I remember I read that. It's not visible because it doesn't advertise any services. Yeah, so this is exactly what we need. So the thing is, we go here and download the code, download the zip, show in Finder, export, sorry, not export, but go to developer, iOS, trust and open. I mean, it's going to be a full miracle if this thing actually compiles. What is this? ESP app. Export. This mobile app is for iOS 10 and above. All code written in Swift, no third-party libraries used. Advanced features like support large PLE messages, modular advanced, blah blah. This is exactly what we need. Done by cool. And should be this one. But why it's called game controller? Oh. But you not. This is stupid example. File open. Developer iOS ESP. Okay. What's going on here? I don't understand that. Developer iOS ESP Easy App Modules. What's going on? Oh, okay. There you go. Try to compile. Of course, it's gonna fail. Okay. It failed, but for different reasons now. Wow. Manager default URLs. Document directory. What the heck is this? Models. Use controllers. I don't understand. What is this? File. Okay. App settings. That's amazing. It's quite big. Mac. Let's try to run it on. I cannot run it on a simulator. Yikes. Where this path comes from. But initializer for condition binding must have option or type, not URL. Yeah, that actually makes sense. But does this mean let's see. I think I understand the error, but yeah, this is what I understand. But did ever URL return optional? You can construct URLs and access their paths. For URLs that represent local files, you can also manipulate properties of those files directly, such as changing the file modification date, blah blah blah. But maybe this used to be a file URL with path, file URL with path, is directory, blah 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 blah. Creating URL from a string, creating file URL. Creating URL by okay. But ours is a file with URL path. Okay. But then how do we check if this is possible? And where the path comes from. Our path comes from, okay. But then why don't we use string? There you go. This should work. Alright, it compiled. Okay, but now the problem is that the simulator cannot use replace. It's not gonna work because the simulator cannot use Bluetooth. So I have to run it on my phone, but my phone is, oh shit. I'm able to do what? Are you crazy? Loading app. Okay, let's try to run it directly on a computer. There you go. Nice. Looks like it's attempting to run. There you go. And it crashed. And now I cannot. That's sweet. This app has crashed because it attempted to access privacy settings data without the usage description. The app's info list must contain NS Bluetooth description key with a string value explaining how the user would use the data. Alright, fair enough. Plist plus. I hope this is it. This is it. Info plist plus. How do I add new one? Blah blah. String value. Okay. But how do I add a description? Okay. We will no. This app would use your Bluetooth to connect to peripheral to external devices. Alright, let's try. Nice. Bluetooth is enabled. Bluetooth scanning device. Central manager discover peripherals. Blah blah. Did discover. It does not discover anything. Okay, then I have to probably try to put it on a phone. And for that, I would need to add devices. How I'm going to do that? And I have to disconnect the ESP for now and attach the phone. So not to make it so boring for you, I'll just turn on the camera so you can look at me. Alright, there you go. Oh, this is already connected, nice. I realize it connected because it's connected directly to the Thunderbolt port. So I'm gonna connect my wife's phone and unlock it. Actually, probably not a good idea to show these things on live stream. Yeah. Probably not a good idea. Alright. So, window organizer, not organizer, devices and simulators. Oops. Connect via network. Crap, this is preparing the phone. Let's see if the phone appeared. Yes. Okay. Crap. Stop. Start. Shit. Let's try to restart the phone. The phone is unlocked. What do you want? Device and simulators. The operation can what? She didn't update her phone. Update. But it says the phone is up to date. Okay. Unpair device. Trust. Okay. Let's see. Building. And now it's gonna say is okay, maybe restart of Xcode. Quit Xcode. Okay, it says preparing. Let's try. Can I disconnect it? Damn. Cannot bear the phone. Okay, maybe I'll go get the tablet. It should be the same, it has Bluetooth, has all the functionalities, so I'll go get one. Nicht mehr. Okay. I'm really not sure if I'm still online or not, but oh, this thing actually okay. Unlock device. She's killing me with this stupid. Oh, I loaded. Alright. Bluetooth is disabled. Enable. Crap. The application stopped. Could not do anything. Alright. But it cannot find. Okay, the application is looking. It's looking like it's trying to find the device. One moment, my phone doesn't support network connectivity. Connect my network. Okay. So the phone is there, and the phone is still there. Okay. So there you go. Let's go to code and show. Now let's run it in this mode. Scanning for devices, but nothing. Okay. No, actually it crashed. Why it crashed? Code when a sender manager discovers a potential peripheral while scanning. Also, one peripheral is connected. Also, once peripheral is connected, cancels scanning. Okay. But then, alright, let's try to debug that. So the problem might not be in the, okay. So now, starting new. Okay. So we currently should have peripheral. Let's see what we have in peripheral. Okay, it has identifier. State disconnected. Good. BC. The hell if I know what this means. But we have RSI, SI. This is the signal. Okay, so we have central, peripheral, advertisement data. Okay, so press F7. But oh, we have name. Okay. Stop. Start. Okay, so peripheral name PO. Peripheral. Peripheral name. Should be new. Oh, it doesn't have a name. So this is simply a bug in the software. But hold on. No, this is optional. But this is bug. Now I see my Swift bug. Okay, we're gonna do if peripheral dot name equals to new, return. You should solve it. So we skip every time when there's no name. Now we should have a name because it's a different device. Peripheral.name. Right, because I have one success. Okay, good. Then we continue to the next one. Cursor evil. Right, because I have one success. Cursor evil. How do you print to debug? Obviously, it's not visible if nothing is seeing it. Debug V. Let's read a little bit about this library. Okay, so what can we do? Let's read the documentation of this library. So, in this setting, start support, standby support for ESP deep sleep by a button or inactivity time, no touchpad yet. Support for battery powered devices. This mobile app gets status for this and this. W is staff. Do it in do not have Bluetooth. Runs in iOS simulator affects code reliability stuff. Do it not have Bluetooth useful to help design UI to test another device models and case sizes. Communication between the app and the ESP32 devices may well be in message. The app acts as PoE got client and the ESP acts as a server for this project, and mobile app have only text limited page messages. First, this is bad English. First field of the message is a code that indicates the content of the action on the message. Okay. If your project needs to send much data, I recommend changing to send binary messages. This project is for few messages per second, less than 20 per second. Okay, that's good. It is more a mobile app limit, more to Android. If your project needs to send more, I suggest use free RTOs that will get data after sending. This supports large messages. Structure module, tools, helpers. Generally, you do not need to change anything in the etude directory, but yes, in other files. Okay, this app consists of connection, main menu information. Oh, there's some buttons here. Oh, okay. Cool. Okay. For each of the view controllers for the main processing BOE stuff have main controller, have templates, ESP IDF mobile app. What? Export iOS device simulator. ESP IDF mobile apps. ESP flashed in. Okay, so it requires the app to install the download to GitHub desktop new app and do it. Okay, so we need to install the other app, IDF app. Okay, so we'll open it in new. There you go. Code download. Downloads. Oh shit. I have prepared a set of applications to serve the basis for those who need to make connected mobile projects with ESP Part 1 firmware. App example. Oh yeah, this is not Arduino. This app for ESP32 is for the latest ESP IDF SDK and entirely made in C++, with the exception of the C code for the BLE connection based on the blah 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 blah. Please access forum blah blah. Okay. This app example of ESP32 advanced features like implementing blah 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 blah, BOE message, structure, prerequisite. The keyboard can be okay. USB board, listen, latest ESP IDF SDK installed. Do I have this? Development framework. Setting up. Oh my god. This becomes too difficult. A configured C++ IDE. I suggest Eclipse or VS Code. Okay. Rich and lightweight, but refactoring is poor. And then Eclipse. I use both. Just editing. Okay. Download. Okay. Open it in your IDE. VS Code. Let's see how to open that. Open project, I suppose. Open folder maybe. Or can I open it from here? File, open. Download. Like this. Yes. Yikes. Doesn't want to open this. No. What was the prerequisite? C++. Open C++ project in Visual Studio Code. So, Shift Command X, Shift Command X. I'll do it on the other screen. Shift Command X, C++. Okay. Good. Then how do I open? Here start extension. When you open a C++ file, you have a syntax highlight. Install a compiler. Choose a compile language before it has blah blah. Check if you have a compiler installed. Make sure your compiler executable is in your platform's path on Windows, Linux, and Mac OS. Extension, you can check updates with tools by opening integrated terminal, control okay, G++ dash var I do have that. Check for clank version. I have that. Visual Studio Community Edition. Visual Studio. Download. Maybe I'm doing something stupid. How can we add files? Existing. There's no project, there's no nothing. Existing files. Okay. Yeah, it's gonna be probably configuration. Ooh, it built successfully. Question is, why did it build it? Okay, let's see what this thing do. Message code. Damn, it's too long for simple thing that I need. Crap. Build, run file. Where Visual Studio for Mac creates C++ applications. Don't need any. Okay, so this is not working like this. Then let's see in code. We have to open everything. Open the folder. Developer, no developer downloads, ESP. Open. Okay. Trust. Main C. Shoot this one. I'm not sure I want to install that. I wonder how many gigabytes is this shit. Okay, fuck it. Yeah. Okay. File, open folder. I just main. Nice. Okay, videos. I made these two Arduino developers in future after I finish part 2 and 3 mobile app samples. How do you install this shit? Prerequisites development kit board can be speed locate loading blah blah USB driver latest ESP IDF SDK. How to upload C++ program to ESP32.
or your other favorite editor like Genie, but I'm going to use Eclipse here. So I'm going to say File, New, C++ project, and select a makefile, an empty makefile project. And now I specify the name of the directory that we created, which from the expressive template. Next and finish. And if we look in here, what we find is the code that was generated for us and built for us from downloading the ESP template and giving it a compile. Well, that's great. So now I'm going to delete the main.c file. This is the main.c file, which is brought in for us when we cloned the template app. But since we're not building a C file, a C project, we're going to build a C++ project. So I don't need that. Now, the next thing I'm going to do is I'm going to copy from my ESP32 snippets, and the links for these will be in the YouTube description. I have a SAM
sample here called Hello World. This is a sample C++ main file. So we'll put it in there, and then later on we will walk ourselves through it. But for right now, I just want to paste it in place. So at this point, we have a build environment which is absolutely perfect for building C programs. So we need to change this to create a build environment for building C++ programs. So we bring up the properties of my project and we go through some steps. So first of all, in my build settings, I'm going to say don't use the Eclipse build environment, use the external environment by running make. Well, that's easy enough. The next thing I'm going to do is I'm going to specify where we should look for header files. Now, there's many of these header files. These are the expressive header files, and rather than type them in, because there's a lot to type in, what we can do is we can take a set that I have pre-built and, again, upload it into the ESP32 snippets, and it's in the Eclipse folder, and I'm going to copy the path to that file, copy the path, and now in my project settings for our CPP free project, I'm going to say I want to import that path there, hit the finish button, and now if we go have a look at what we have, we shall find that we have a bunch of directories for looking for header files. That's great. And there's one final thing that needs to be done in our project. We go up to properties again, and in the indexer tab, no, that's not right, in preprocessor includes, yes, in providers, preprocessor includes providers, we select the CDT GCC built-in compiler settings here, and we change this to be our extensa ESP32 ELF GCC setting. And this basically says that the extensa ESP32 compiler is going to be run to generate the compiler settings, which are going to be read by Eclipse in order to determine the location of some of the include files. So I hit the OK button on this, and what we will now find is that if we open up our Hello World programs, we see that we are greeted with some warning errors, and that's because we haven't yet run a rebuild of the indexer. If I say that I want to rebuild the index, if all has gone well, those errors have gone away. And now, after those steps, we're ready to code. So this is the sample program that we brought in, and I'll take us through this in detail. This is just a C++ program, and my goal is not to teach you C++. And what we do is we have our app main entry point. Now, the app main entry point is where control is given when the ESP32 starts up. It looks for a function called app main. But if you've studied C++ at all, you may have heard a concept called name mangling. And what that means is that in C++, I can define a function called f, which takes an integer. Great, there's a function called f, which takes an integer. And I can create a function called f, which, for example, takes a double. Okay, so there's two functions with the same name that take different input types, and depending upon what parameter I call that function with, the correct function will be called. So if I call f and pass it as a parameter an integer, this function will be called. And if I call f and pass it a double, this function will be called. Now, in C, you can't do things like that. So how does the compiler know which function to call? And the answer is that when this code is compiled, two functions are created, but they're not called f. Instead, they are decorated or mangled to include the parameter types expected by the function. So this is what's called name mangling in C++. Now, by and large, it doesn't show up for us. However, if we're calling from a C program, this app main function is not actually called app main. It's called app main with some kind of mangling that says it takes as a parameter a void. So the solution for this is this extern double quotes C. And what this does is this declares the name of a function to have C bindings. So this function
Okay.
function will be exposed without name mangling, and that's the secret sauce in order to call the app main function from outside of a C++ environment. So looking at this, so we've created a C++ class. It's called greeting. It's got two methods in it, hello English and hello French, and it's got another method called setName, and name is a private variable. So for example, when I create my greeting class, I can set the name to be my name, and then I can call the method hello English, which will echo hello my name, and if I call hello French, it will log bonjour and my name, and there we created a class which encapsulates this. Notice also we're able to use C++ standard template library functions. Now again, this is not a C++ education tutorial. This is as much showing you how to build it in an ESP32 environment. But the standard template library gives us things like dynamic strings. I can concatenate onto a string. I can pass a string around by copy or by reference. All kinds of good things. And the standard template library also gives me things like hash maps and lists and vectors and queues and all kinds of other wonderful, wonderful functional libraries which I can use in my application. So what remains now is to compile this program. I'm going to add a build target. A build target is a way to run the make system from within side Eclipse. So I run the make system and it compiles and it's done. If I run it again, it doesn't have to compile anything because everything's clean. If I change my source file, hit save, compile it. Oops, sorry, let's hit that button again. Compile it and it rebuilds the hello world. Great. Now we could flash it from memory, but let me flash it from here. And I've just realised I have not powered up my ESP32. So let me power up my ESP32, and because I'm using VirtualBox here, let me map it like this, and now I can run make, flash, and monitor. And this is now going to push our application out to my ESP32 and run the monitor as soon as it starts. So it's flashing, 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 and it's running, and we get the log messages, hello Neil and bonjour Neil. And that was because the code here created an instance of the greeting class, set the name Neil, called the hello English method, which logged hello and then my name, and hello French now gave us the bonjour Neil entry.
So we have to find a way to compile and upload C++ up to
Hi guys, and welcome to another ESP32 technical tutorial. This
from command line. Okay. Compile C++ from console macOS. How to compile C++. This project makefile is assumed the directory this makefile resides in is a project subdirectory. Hard to run file Mac. Okay, so just make no rule to make target. Install program to make file. No rule make target. Okay. Okay, I think I'm gonna call it a day. I think I streamed quite a long time, so I don't think I can get to a solution today. Let me see how to stop this stream. Okay, let's try. Alright, that's it. I'm done.